Welcome to Section B of the IB-MA-HL. International Baccalaureate Mathematics Analysis and Approaches Higher Level Paper 1 Specimen. This section contains questions 10, 11 and 12. Let f of x equals log of 5x over kx, where x is positive and k is a positive real number. Part A. Show that f prime of x equals 1 minus log 5x, all over kx squared. Using the quotient rule, we get 5kx times 1 over 5x, minus k log 5x, over kx all squared. Simplifying, the k and x cancel, giving 1 minus log 5x over kx squared, as required. Part B. The graph has exactly one maximum point P. Find its x-coordinate. Setting the derivative to 0, 1 minus log 5x equals 0. Therefore log 5x equals 1. So x equals e over 5. Part C. The second derivative is given. Show that the point of inflection Q has x-coordinate 1/5 e to the 3/2. Setting the second derivative to 0, 2 log 5x minus 3 over kx cubed equals 0. This gives 2 log 5x equals 3, so log 5x equals 3/2. Therefore 5x equals e to the 3/2, so xq equals 1/5 e to the 3/2. Part D. The region R is bounded by the curve, the x-axis, and vertical lines through P and Q. Given the area is 3. Find k. The area is the integral of log 5x over kx, from x equals e over 5, to 1/5 e to the 3/2. Substitute u equals log 5x, then do equals dx over x, giving the integral of u over k do. Integrating gives u squared over 2k, which is log 5x squared over 2k. Evaluating the limits. At the upper limit log equals 3/2. At the lower limit log equals 1. This gives 5 over 8k. Setting this equal to 3, we find k equals 5 over 24. Part A. Express minus 3 plus root 3I in the form re to the I theta. The modulus r is the square root of minus 3 squared plus root 3 squared, which is 2 root 3. The argument is pi plus arctan of minus root 3 over 3. Since the point is in quadrant 2, this gives 5 pi over 6. Therefore, minus 3 plus root 3I equals 2 root 3e to the 5 pi I over 6. Part B. Find the cube roots of minus 3 plus root 3I. Using de Moivre's theorem, the three roots are given by the cube root of the modulus times e to the I times 5 pi over 18 plus 2k pi over 3. For k equals 0, 1 and 2, we get the three roots. U equals 12 to the 1/6 e to the 5 pi I over 18. V equals 12 to the 1/6 e to the minus 7 pi I over 18. And W equals 12 to the 1/6 e to the 17 pi I over 18. Part C. On an Argand diagram, the points U, V, W form a triangle. Find its area. The triangle is equilateral. The area of each congruent sector is 1/2 times the product of two side lengths times sine of 2 pi over 3. Multiply by 3 for the whole triangle. This simplifies to 3 root 3 over 4 times 12 to the 1/3. Part D. By considering the sum of the roots, show that cos 5 pi over 18 plus cos 7 pi over 18 plus cos 17 pi over 18 equals 0. The sum of the three cube roots is 0. Writing the roots in trigonometric form, we get this expression. Equating the real parts to 0. And noting that cos of minus 7 pi over 18 equals cos of 7 pi over 18. We obtain the required result. The function f is defined by f of x equals e to the power sin x. Part A. Find the first two derivatives and hence find the Maclaurin series up to the x squared term. Using the chain rule, f prime of x equals cos x times e to the sin x. Using the product rule, f double prime of x equals e to the sin x times cos squared x minus sin x. Evaluating at x equals 0, we get 1 for all of them. Substituting into the Maclaurin formula gives f of x equals 1 plus x squared over 2 factorial. Plus higher order terms. Part B. Show that the coefficient of x cubed in the Maclaurin series is 0. Method 1. Differentiate f double prime. Differentiating f double prime gives this expression. Evaluating at 0, we get 1 times 1 minus 1 times 1, which equals 0. Therefore the coefficient of x cubed is 0. Method 2. Substitute the Maclaurin series for sin x into the series for e to the x. The series for e to the u with u equals sin x. Using the Maclaurin series for sin x. The x cubed term from sin x contributes minus 1 over 3 factorial. And the sin cubed over 3 factorial contributes plus 1 over 3 factorial. They cancel, so the coefficient is 0. Part C. Using the Maclaurin series for arctan x and e to the 3x minus 1. Find the series for arctan of e to the 3x minus 1 up to the x cubed term. First, the Maclaurin series for e to the 3x. The Maclaurin series for arctan u. Substituting e to the 3x minus 1 into the series for arctan. Simplifying, the x cubed term becomes 9 over 2 minus 27 over 3, giving minus 9 over 2. So the series is 3x plus 9x squared over 2 minus 9x cubed over 2. Part D. Hence or otherwise. Find the limit as x approaches 0 of f of x minus 1 over arctan of e to the 3x minus 1. Substituting the series we found for f of x minus 1 and for arctan. Factoring x from numerator and denominator. As x approaches 0, the limit is 1 over 3. This concludes the walkthrough of Section B, and of the entire specimen paper. Good luck with your preparations.
Why, baby, why? Why, baby, why? Why, baby, why? I just wanna know. Why, baby, why? Why, baby, why? Why, baby, why? I just wanna know. Did you pause for a minute? Did you even feel it? Yeah, you felt it. For a minute. Why, baby, why? Why, baby, why? Why, baby, why? I just wanna know. Why, baby, why? Why, baby, why? Why, baby, why? I just wanna know. It was in the air. It was a smile. I was humming. You were whispering something. Did you feel it? Did you ever feel it?